If 8 hypersonic missiles were launched toward the USS Gerald R right now, the strike group would have less than 40 seconds to survive. At Mach 10, a missile travels more than 3 kilometers every second. That means radar detection, threat classification, command decisions, interceptor launch, and guidance corrections all compressed into half a minute. Iran claims its Fatu-2 can maneuver at hypersonic speed. The United States Navy deploys the RIM-162 Evolved Sea Sparrow missile, ESSM Block, as part of a layered defensive shield. But when physics meets reaction time, which system performs more effectively? This is not about rhetoric. It is about math. The USS Gerald R does not operate alone. It sails within a carrier strike group built around the Aegis Combat System, a network linking radar, fire control, and interceptors into a single defensive architecture. Our Labeur-class destroyers extend the radar horizon. E-2D Hawkeye aircraft provide airborne early warning. Multiple ships contribute interceptors. Defense is layered. The outer layer relies on SM-6 interceptors designed for long-range engagement. The mid-layer relies on ESSM Block 2. The inner layer relies on rolling airframe missiles and the Phalanx close-in weapon system. 3 rings of defense. 1 shrinking clock. Assume radar detection at 120 kilometers. A Mach 10 missile travels roughly 3.4 kilometers per second. Impact in approximately 35 seconds. Subtract several seconds for detection, confirmation, and fire control assignment. Roughly 30 seconds remain. ESSM travels at about Mach 4, approximately 1.3 kilometers per second. If launched at 40 kilometers from the carrier, intercept occurs near the edge of its engagement envelope. The margin is narrow. Now, change one variable. Detection delayed 280 kilometers. Impact time drops to roughly 23 seconds. The engagement window collapses. At that point, speed becomes the attacker's advantage. But hypersonic weapons are not defined by speed alone. They maneuver. If a glide vehicle shifts laterally by several kilometers during its final seconds, the intercept solution must update continuously. ESSM Block 2 carries an active X-band seeker, allowing terminal homing without constant ship illumination. Its maneuver capability is estimated above 50 G. Yet even extreme maneuverability cannot overcome insufficient time. If the intercept geometry collapses inside 20 kilometers, engagement may occur only seconds before impact. Now increase the complexity. Not 8 incoming missiles, 20. Standard naval doctrine often allocates 2 interceptors per inbound threat. 24 incoming missiles would require 48 SM-6 interceptors in the outer layer alone. If 30% survive that initial engagement, 7 missiles remain. ESSM would then fire 14 interceptors in the mid-layer. Manageable once, but vertical launch cells cannot be reloaded at sea. Magazine depths becomes a strategic constraint. If a second wave follows, inventory, not technology, becomes the limiting factor. Assumed to hypersonic vehicles survive to 5 kilometers. Even slow to Mach 8. Impact time is under 2 seconds. At that distance, close-in systems operate within an extremely compressed window. The defensive battle transitions from interception to survivability. There is another variable, targeting. A carrier traveling at 30 knots moves nearly 1 kilometer every 2 minutes. 10 minutes of targeting delay equals roughly 9 kilometers of displacement. Without persistent over-the-horizon tracking from satellites, drones, or aircraft, even a Mach 10 weapon risks missing a maneuvering naval target. Speed compresses time. It does not eliminate targeting uncertainty. So, can ESSM intercept a hypersonic missile against isolated or limited salvos integrated within a layered Aegis network? It can contribute significantly to interception. But it is not a standalone shield. It is a mid-layer attrition system operating within strict physical limits. Its effectiveness depends on early detection, outer layer, degradation, fire control, precision, and sufficient magazine depth. Physics limits reaction time. Inventory limits and saturation defines the true stress point of the system. The decisive contest is not ESSM versus FAT. It is systems versus systems. Sensors versus maneuver. Networks versus salvos. In modern naval warfare, survival is determined not by the fastest missile, but by the side that integrates detection, computation, and interception under extreme time pressure. In a hypersonic engagement, time is the only resource that cannot be replenished.